Good morning, students. Welcome to today's session. I think every one of you understood what and all we have seen so far in the last videos, and I hope every one of you understood all type of problems and everything under statistics. So, as I already told earlier, that is the uses of sample papers is very important than your book, right? So the statistics lesson completed fully with all the different kind of questions, and also we have seen some extra questions also. So just take your sample paper and try to work out the sums under statistics, right? Today we are going to see a new lesson, that is chapter 15. So the title of the chapter is probability. So already you know about the word probability. From your lower standard itself, you are seeing that word. So probability or chance of an event is nothing but unpredictable events. So if you cannot, if we cannot predict the results of any event, then everything comes under the probability only. A well-known example of probability is tossing a coin. So when you're tossing the coin, so what will land it? So either head or tail. The coin will shows either head or tail. So it is not predictable. You may predict head or tail. Okay, that is only for 75%, not 100%. Right? So if you're tossing a coin, that two events are there. That is either the coin will show head or tail. So 50% chances are occur on head and tail. So this kind of activities, that is cannot predictable, and also 50% among the events. So everything. So this kind of experiments, everything comes under the topic probability. Right. So before entering into the session, first look at the definition of the probability. So the definition of the probability is nothing but chance of happening or not happening of an event, or chance of occurring or non occurring of an event. We can define anything. Okay. And some examples, that is some examples is nothing but will it raining tomorrow or is it raining today, and what is the chance of winning the game, and what is the chance of getting promotion in any field. So everything cannot predictable. Okay, that only assumption can be made, right? So which events everything under assumption, so everything comes under the probability, right? And here experiment. So experiment, what is experiment? So tossing a coin, so that also an experiment. Throwing dice, that is also experiment. Okay, so these are the well-known examples for experiments: tossing coin, throwing die, because we have oftenly used this kind of experiments, everything. Okay, in our lower sections, right? Tossing coin, throwing die, and taking ball from a box. That means suppose if a box contains two different or three different colors of balls, that is yellow, red, blue. So if you are selecting any one ball randomly, that is without looking into the box, so everything comes under probability, right? And what is the probability, what is the formula for the probability? So the probability of an event E. So before that, so you should know about the difference between experiment and the event. Okay, so what is experiment means? Tossing coin and throwing dice. So everything experiment, but the event is nothing but the experiment contains events itself. Okay, for example, if you're tossing a coin means what are the possible outcomes? Head and tail. So both are called events, right? So head and tail are events of tossing a coin. And when you're throwing a die, what are the possible outcomes? So the number 1, 2, 3, 4, 5, 6. So this 6 numbers are outcomes through the experiment, or you can call them as a event, right? Now understand. So what is the difference between experiment and event? Okay. Similarly, suppose if you're choosing any ball, okay, from a box, right, from a box, so that choosing a ball is nothing but experiment. Okay, so which type of ball we can need, that is whether what color of ball we need. So that is comes under event, right? So formula for the probability. So probability of an event E defined by the formula P of E equal to number of favorable cases divided by total number of cases. So here capital E stands for event. So now only I said what is event and what is experiment. Okay. So event is nothing but one of the part or subset of experiment. Okay. So number of favorable cases. Then what is favorable cases? So favorable cases is nothing but the question. That is, suppose when you are tossing a coin, if you need head or tail, means everything comes under the favorable cases. So that is called favorable cases. And total number of cases. So total number of cases is nothing but total possible cases. Okay. So total possible cases. For example, throwing a die, right? So how many total number of cases are there? 6, because 1 2 3 4 5 6 numbers possible. Okay, so that is nothing but comes under total number of cases. But favorable cases, suppose if I ask the question, find the probability of getting odd numbers when throwing a die. Okay, so here when throwing a die, so the die contains 6 numbers, so that comes under total number of cases. And favorable cases means odd numbers. What is it now? What is the probability of getting odd numbers? That comes under favorable cases. So favorable case is nothing but the question, that's it. Okay. And the next one, we can define the probability with the notation n of a by n of s. Then what is s and a? So a is nothing but event. For example, when you are tossing a coin, head and tail or event. Okay, so if you take, if you want to find out what is the probability of getting head, means that head you can define by the notation as A, B, C. So likewise, you can use at any alphabet. That is, but you should be use the capital letters only. Or you can use the events and all E1, E2, E3, E4, etc. according to the questions. Suppose 2 questions are there asking in the question, means you can take the first one as E1 and second one as E2. So we can give the name, that's it. Okay. And S means sample space. Okay, S stands for sample space. So sample space is nothing but total number of cases. Okay, so the notation for the total number of cases is nothing but n of s. So number of event divided by number of sample space, that is the meaning. Okay, so we can define the formula either in words like this or in notation like this. Okay, so look at one example now. What is the probability of getting head when tossing a coin? So what is the probability here? Before going to solve the probability questions, first check or first identify the experiments and the events. So here the experiments is nothing but tossing a coin, that is experiments. Okay, experiment. And here event is nothing but the question. So what is the probability of getting head? So getting head is nothing but your question, that is favorable cases. So these two are very important. So before going to solve any probability questions, first ensure that which is experiment and which is event. Okay, so here tossing a coin experiment and getting head is nothing but event. Okay, now we are going to solve. So what is the formula for the probability? N of a by n of s, that is number of cases in favorable cases and the number of cases in total number of cases, that is the meaning. Okay, so look at the solution now. So S equal to, what is S? I said S is nothing but sample space. So sample space is nothing but total number of events. So here head and tail are the total number of events, so they are all called sample spaces. Okay, so next N of S, that is number of elements in S. So how many elements are there? Head, tail. So 2 elements are there, so that is called the N of S. Right, and next we are going to define event. As I already told that if you want to classify the events, means we can give the name as E1, E2, E3, E4 like that, or you can take A, B, C also, that's your convenient. Okay, so I took here E1. So E1 is nothing but the event of getting head, because that is our question. So head, how many heads are there in the total cases? Only one head, so I represent inside the bracket. And n of E1 equal to, so n of E1 means number of elements in E1. So this is E1. So this is E1. How many elements are there inside it? Only one, that is head. So n of E1 equal to 1. Okay, next we are going to substitute the formula. So the formula is nothing but P of E equal to N of A by N of S. So here E1 is nothing but E1. So P of E1 equal to N of E1 by N of S. The same formula format. So what is N of E? 1. And what is N of S? 2. So the answer is 1 by 2. Suppose, what is the probability of getting tail? Here also the sample space same, that is two cases only, and let the E2 be the event of getting tail. You can take like this. So inside the bracket only T will come, and N of E2 also 1 will come. So the probability also 1 by 2 will come. Okay, so the while you're solving the probability questions, two things is very important. So sample space, okay, so sample space and also events, right? So first we have to find out S value always. That is, S is nothing but possible outcomes of a particular experiment, and next N of S. That means you can count the elements inside the bracket and write it. Next you can define the elements, that is events, according to the question only. So here question is nothing but getting head. So how many heads are available? Check in your sample space, that is in S. Then after that count the number of elements inside the bracket and write it here, and then divide this answer by this answer. That is our question, that is our answer. Okay, so that is a procedure for solving probability questions. Okay, so look at the next example. So what is the probability of getting at least one head when tossing two coins? So here which one experiment and which one event? So here tossing two coins. So tossing two coins is nothing but your experiment, and what is the event here? So getting at least one head. So that is called the event here. So first what we need, first sample spaces. So when you are tossing two coins together simultaneously, so both coins will be landed. Okay, so what are the possible cases? Okay, look at S now. So head. So here how can we represent? Means suppose we are tossing two coins, both coins definitely should be landed. So one coin may show head and another coin also may shows head. So both are head, in both coins shows head, that is the meaning. And TT means the both coins may show tails, or the first coin shows tail and second one shows head, that is TH. And HT means the first coin may shows head and second may be shows tail. So only this much possible cases are arise when you are tossing two coins together at the same time. Okay, so next we are going to find out the number of S, that is N of S. So count the elements, how many elements are inside? 1, 2, 3, 4 elements. So N of S equal to 4. Okay, next we are going to define event. So what is event here? Getting at least one head. What is the meaning of at least? So at least means minimum. Okay, so minimum I need one head from the sample space, that is the meaning. So minimum one head means you can add maximum also. Maximum how many heads are there, you can include that also. So I need minimum one head. So let us take here one head is there. So 1 and 2 we can join the two heads also, because we need minimum one head. Okay, but this it is not possible to include because there is no head in both coins, right? So let E1 equal to the event of at least getting at least one head. So the possible cases are head, tail, head. Okay, so now we are going to count the elements inside the bracket. So 1, 2, 3. So totally N of E1 equal to 3. Now how can you write the answer? We have to divide this answer by this answer, that's it. So P of E1 equal to 3 by 4, right? So that is the answer for the second one, right? So look at the next example. What is the problem of getting prime numbers when throwing a die? So here the experiment is nothing but throwing die and even getting prime numbers. Now what are the possible chances? That is S value. So 1 to 6 numbers will come, and then count all the elements inside S. So that is N of S equal to 6. Next we are going to define the event. So getting prime number is the event. So let I define as E1. So E1 equal to the event of getting primes. So out of these 6 numbers, which are prime numbers? So 2, 3, 5, these 3, and count and write. So 3 elements are there inside the bracket. So N of E1 equal to 3. And what is the probability now? We can define this one by this one. So the answer is 3 by 6. So when we simplify this, we'll get 1 by 2, right? So that is the answer. So let us continue in the next video.